Welcome to our Mathcast on metric conversions. Our goal is to help you better understand the concepts at hand when you need it and at your own pace. We hope you enjoy this Mathcast on metric conversions.
Okay, here we have a chart on the metric conversions, and it shows the kilo, the heka, the deca, the key units, which is meters, grams, and liters, deci, centi, and milli, and there's an acronym. King Henry died unusually drinking chocolate milk, which the K goes with the kilo, the H goes with the heko, the D goes with the deca, the U goes with the unit, the D goes with deci, the C goes with centi, and the M goes with milli.
Okay, in this problem we see that we need to convert 1,000 meters into some millimeters. We go to the chart and we see that we must move the decimal point 3 to the right to get to millimeters from key unit, which is meters. So we go back and move the decimal point 3 to the right. 1, 2, 3. We add the zeros. We see that we got 1 million millimeters as our answer. We got 1 million because when we saw that we need to get to millimeters from meters, the only option is to move the decimal point 3 to the right because it takes 3 steps down to get to the millimeters area.
We can see that we need to make 250 kilometers into blank centimeters. If we go back to the chart, we can see we need to go 5 to the right and down. To do that, we need to move the decimal 5 to the right from kilometer to centimeter. To do that, we need to move the decimal 5 to the right. 1, 2, 3, 4, 5, and fill in the zeros. We see that our answer is 25 million centimeters.
This time we see that the only way to get from centimeters to meters is to move the decimal point to the left. As we go to the chart, we see that we must move the decimal point 2 steps to the left to reach meters. Now let's do it out and work out our answer. 1, 2. Our answer is 3.59 meters. I got 3.59 meters as my answer because when I have 359 centimeters, we need to change it into meters. We can only do that by moving the decimal point to the left, because if you move it to the right, only millimeters is left. So I need to move it 2 steps up to get from centimeters to meters, as we did earlier while solving this problem. This problem says the width of a football field is most likely A, 1 centimeter, B, 100 meters, or C, 1 kilometer. If you have seen a football field before, you probably know that a football field isn't 1 centimeter. If it was, football players would be playing on a pencil eraser size field. We can cross out that possibility. The 1 kilometer is about 3/4 of 1 mile. Football players would be running a cross-country race if they constantly had to run back and forth. We can cross out that option. All we have left is 100 meters, and that is the answer. The answer is correct because if you look at a football field, you know that each half of the field is 50 meters. If you can add 50 plus 50, you get 100. This also uses a lot of common sense, understanding, and the order of elimination. In this problem, the height of a Diet Pepsi bottle is most likely A, 5 centimeters, B, 25 centimeters, or C, 1 meter. A water bottle is about as tall as a Pepsi bottle. 5 centimeters is probably about 1/4 of a Pepsi bottle. A meter is about up to a doorknob, so it is way too large. Therefore, it is 25 centimeters. There are about 1.6 kilometers for every mile. If Sweeney ran a mile in 6 minutes, about how many meters was he going per minute? Round your answer to the nearest whole number. Let's use what we know. 1,000 meters are in 1 kilometer, so we have the leftover 0.6, which would end up as 600 meters. We now add the 1,000 with the 600 and get 1,600 meters. Now we need to divide the 1,600 meters by the 6 minutes to get our answer. Okay, now we need to do the math. 6 goes into 16 two times. We add our 2 up here. That would be 12. So we subtract the 12 from 16. We get left over with 4, and then we'd bring down the 0. We would get 36. And because we would do 6 times 6 would be 36, and we couldn't add another one, so we'd 6 sixes. And we would be left over with a 4 again, so we'd have to bring down the 0. And we get 36 again. Bring the 6 back up here. We'd be left over with 4. Now we need to go into the decimal points and bring the 0 down to the 4 and get 40, which once again would be 36, which would be 6. We now realize that it's going to keep on going on as 6 forever. So we must turn this 6 into a repeating 6 so we don't have to write it all out. Repeating 6 would be rounded up to a 7, so you would change our 266 to a 267 meters per minute. Sorry, Sweeney. When we do the math, we figure out that we get 267 meters per minute. The 6 would be a repeating decimal, so we'd have to turn that into a 7 to get our answer. When we get 267 meters per minute, we find out that it's a pretty straightforward answer. All you need to do is divide 106.00 meters by 6. But we need to add the label because it's a story problem, which would be meters per minute.